solve for the triangle or triangles, because there could be more than one, with b equals 4, c equals 8, and angle b equals 20 degrees. This is the classic ambiguous case because the side angle case, and there could either be 0, 1, or 2 triangles that meet this criteria. So the best way, in my opinion, to do this is to first draw your line that you don't know. This is the side I don't know. Draw it down here, so we don't know how long that's going to be. Draw your angle as accurate as possible to 20 degrees. That's about 20 degrees right there. Draw your sides as accurate as possible. Now this is going to be my 8. That side's going to be 8. And this side over here is going to be half as big as that, which is about like here, 4. So it's going to be somewhere probably right there. That looks about right. Well, the trick is, if that's 4 and that's 20 and that's 8, could you also have put the 4 inside here? Could you also have done that? And the answer is most likely you could have, but how do you know for sure if that would have happened? Well, you find the height. You drop the height straight down. It's not going to let me drop it straight down because you drop the height straight down right here. That's your h. And you find out how h is related to 4 and 8. Well, specifically 4. So what does h equal? H, notice that this would be a right triangle. If that h was down here, this 20-degree angle would be a right triangle. So the sine of 20, the sine of 20 would have equaled h over 8, right? Which means h equals 8 times the sine of 20. Let me do that again. That was a little sloppy. The sine of 20 degrees equals the opposite over the hypotenuse, h over 8, which means that h equals 8 times the sine of 20. So punch in 8 times the sine of 20 in your calculator. Tell me what that equals approximately, which is approximately 2.73. That's about what h is. So since this side is between h and 8, that means that I can draw 2 different triangles. Okay? So I do know that there's going to be 2 triangles. And so now let's find one of our triangles. Well, how do I find it? I do the law of sines, right? The sine of 20 over 4 equals the sine of b, no, not b, c, I'm trying to use these, the sine of c over 8. So tell me what c equals.
Or wait, sorry.
So c equals, and this is my c right here, 43.16 degrees. That's my c. It's right across from the 8. Now, how did I know it was this one that it was giving me and not this one that it's giving me? How do I know that that's that one, not this one? This is going to be called my C1, and this is going to be called my C2. How did I know I just got C1, not C2?
Because it's acute.
Yeah, for 1, it's acute, and for 2, that's the only thing that sine inverse will give you. Sine inverse will only give you acute angles.
Mm-hmm.
So we took the sine inverse of something, and that has to be less than or equal to 90 degrees, or less than 90 degrees. The absolute value of that has to be less than 90. We know that because of the range domain of sine inverse, rather. Okay? So now I can find this is my C sub 1, right? So what's this angle going to be? This is going to be called A sub 1. What's A sub 1 going to equal? How do I find A sub 1? Well, I know 20, and I know that. So I do what? 180 minus 20 minus 43.16, which equals
116.84.
116.84. And then how can I find A down here, which will be called A1, A sub 1, the side A sub 1? How can I find that?
Law of sines.
Law of sines. So I'm just going to law of sines. So you can figure that out on your own. I'm not going to do that for you. Let's do the next part. The next part is, well, how do I find the other triangle? How do I find this angle right here? C sub 2. Any ideas? I'm glad we're doing this problem. Well, we know this angle is the same as what other angle? C sub 1 is the same as what other angle on this picture? This one right here. So what's C2 going to equal?
That one, 180 minus.
180 minus C1. C2 equals 180 minus C1. They're supplements of each other. So what does C2 equal? Subtract that from 180.
136.84.
136.84. So that's that angle. Now how can I find A2?
180 minus.
Just do the same thing and then use the law of sines to find this A sub 2 right here. Side A sub 2, and then you've got your two triangles. Okay? That's an example of a ambiguous case, side-side angle, ambiguous case with two triangles, and that's how you find the two triangles.